Hey, howdy, Danny.
Hey, how's it going, Michael?
Pretty good, pretty good. How are you?
Doing well. Let's see, get this scene set up. Fantastic. All right, I got you on stream right here, and what a cool background. Holy cow.
Thank you.
Yeah, we just got done watching your video. Sorry, I'm a little bit late. We wanted to get through the whole thing before
Oh,
we started
cool.
this up. But man, excellent job. What an excellent piece of science communication there.
Thank you
Um,
very much. I'm glad you all
yeah,
enjoyed.
it was phenomenal. And again, chat, if you haven't yet had a chance to click that link, and I'll post it again for you. Um, Give it a thumbs up, leave a comment, all the typical YouTube stuff. Go ahead and do that. It would help Michael out. He'd really appreciate it. And we need more of this kind of really high quality science communication by actual scientists. So I want to encourage that as much as I can. Uh, Really cool stuff, Michael. How long did that take to make?
So, I have been working on and off on that video
Mm-hmm.
for over a year now.
Nice.
It was a lot of time. Now, given I was not working consistently for
Of
a year
course,
on
yeah.
it, but
Yeah.
a lot of it in the last, probably 5 or 6 weeks, I got a lot of the graphics and things like that animated
Nice.
together and all that.
Yeah, yeah. I hope this comes across as a compliment, because it's intended as such. It really reminds me of some of Brian Eng's videos. Um,
I take a lot of inspiration from his
yeah.
general format. I like
Uh-huh.
sort of this long form, but not, it doesn't need to be an hour or anything, but long form
Right.
enough to get into some of the details of
Mm-hmm.
things, not feeling the need to dumb it down. It sort of
Right.
the idea of trying to make sort of a short form documentary almost is something that
Uh-huh.
appeals to me a lot. So yeah, Brian's stuff is also great. Definitely go watch that as well.
Yeah, yeah. I think it's really cool how you're not drowning everybody in jargon, but you're not shying away from these technical terms either, and you're kind of providing a nice overall feeling for what the science is like. So even if somebody doesn't understand everything in it, they're at least getting a taste for what taphonomy is all about, what it's like to do field work and lab work, and it's kind of aspirational in that sense, where somebody can watch it and go, I don't understand all of this, but I really want to. I feel like it entices people to want to learn more. That's the impression I get anyway. So
Thank you. That's the hope, at least. The
yeah,
idea with that video was I was trying to get across, the actual results of the paper and whatnot, obviously,
right.
but a lot of it also was sort of spurred by the fact that in the paper we have a methods section and all that,
Mm-hmm.
but there isn't always a place in the paper to show the full process of
Right.
like on the
Yeah.
ground, what was it like to do this science and
Uh-huh.
what led us to do the things that we did.
Right.
A method section gets at some of that, but I had a lot of this video footage and things like that that I'd taken during the experiments that didn't end up getting included in the paper. And I thought
Mm-hmm.
that sort of having a video that's more about, I mean, yes, is about the science, but it is also about how do we do science.
Right.
That was part of what drove me to do that video.
Really cool stuff. Yeah.
Thank you.
Um, to get us started off here, um, especially for anybody who's just kind of trickling in right now, given this is Twitch, there are people, you know, just clicking on the link to come in and people doing laundry and all kinds of stuff. So it's nice to kind of bring people up to speed every once in a while. I try to remember to do that. Tell us a little bit about yourself. Who is Michael Chiappone? Where does he work? What's he all about?
Yeah. Well, I guess y'all have already seen me apparently, but howdy, I'm Michael Chiappone. I am a PhD student at the University of Minnesota. And I work on, as is evident both from the video and from my background, I work on taphonomy, especially taphonomy as it relates to fluvial environments, rivers, and their floodplains. I want to know how animals and other organisms that live and die in rivers and their floodplains end up in the fossil record for us to actually be able to do paleontology on.
Nice. Yeah. I mean, fossils are like the raw material of our science. That's our data as paleontologists, and understanding where those data come from, I think, is crucially important. And we'll get into why that's important in a little bit. But continuing on the background theme here, where did you grow up? And how do you think that influenced your interest in the natural world and maybe in paleontology too?
Yeah, so I am not from Minnesota. I am originally from Texas.
Hmm.
And until I moved up here for grad school, have never lived anywhere else in my life. We moved around a lot in Texas. I've lived in many different parts of the state. Um, but considering it's quite a big state, you could move 5 hours away from where you lived and still be in Texas.
Right. California's the
So
same way. Yeah. Yeah.
yeah, yeah.
Yeah.
So I grew up in various different parts of Texas, most recently the Austin area, kind of the hill country area for people that know that area. And I think it definitely had an impact on me going into natural sciences just because Texas as a state is extremely, because it's so big, really is the main reason. It is an extremely diverse state in terms of geology and biology. There is a lot going on. And
Hmm.
it is also often pretty easy to access. There are, if you're on the geology side, there are rivers and creeks that move right around you that are both demonstrating fluvial processes and also unveiling the rocks underneath them for people like me when I was living in North Texas as a kid, running around in the creeks looking for Cretaceous marine fossils and things like that. Or living in Central Texas, you might go into the early mid Cretaceous where both when I was growing up very young and later on when I moved back, be surrounded by dinosaur trackways and things like that, of which
Right.
there are pictures of me when I'm very small sitting in the trackways of big theropods like Acrocanthosaurus and such,
Uh-huh.
that definitely left a lasting impact on me. I have a, you know, kind of a soft spot for trackways. I think they're very cool, probably because I grew up around them.
Hmm.
And then on top of that, not only from a geological and paleontological standpoint, but also Texas is so big and diverse that there are so many different kinds of habitats and living organisms around you,
Oh
depending
yeah.
on where you go.
Hmm.
And so I later on in my, sort of tenure in Texas, when I was an undergrad, got into things like birding,
Nice.
and was able to access all kinds of different habitats from wetlands to more plains areas to, areas like the hill country that have big, tall limestone cliffs and things like that, all the way down to the coast where you get the marine stuff that, you know, you don't always get everywhere. It's different, birding in Minnesota than it is birding in Texas.
Hmm.
So I think
Absolutely. Yeah.
all of those different things had lasting impacts on my decisions to go into the natural sciences for sure.
Nice. Nice. Um, Again, for the benefit of anybody who's just tuning in right now, let's really make sure that we hit this point. What is taphonomy? Maybe we'll explain the origins of that word too, to help the
Yeah,
concept
yeah.
really sink in here.
Yeah,
Yeah.
so let me start with the origins of it. If anyone was around during the video, I go into this a little bit, but I'll go into it a little more heavily here. So, flashback to the 1940s,
Hmm.
when paleontology, which is already relative to most sciences, a very young science.
Oh yeah.
Like paleontology, the word goes back to, like
The
basic
1830s. Yeah.
1830s, your
Yeah.
Victorian Britain kind of times.
Hmm.
By 1940 or so, 100 years later, things have progressed, but paleontology is still an extremely young field. And one of the
Hmm.
things that people had rarely delved into in any serious way was
Hmm.
actually how fossils happen. Where
Right.
do fossils themselves come from?
Uh-huh.
People were understandably very excited about the fossils themselves. Like, what is this thing that I have found? And what was it when it was alive? What does that mean for the history of life on our planet?
Right.
But like you said, the fossil record is our data set as scientists. That's what we have to go off of.
Hmm.
Um, and it's sort of an important thing to know in the sciences where your data is coming from in order to know what limitations you have when you're dealing with it.
Right.
And so in 1940, in walks Ivan Yefremov, who is a Russian paleontologist who is a fascinating person, by the way. I don't get to go into it in the video, but
Uh-huh.
he is fascinating.
That photo that you had of him in the video is really intriguing. He looks like your archetypical explorer with like military
Right.
garb. He's in a tent. He's got like a rifle or something hanging next to him.
Yeah,
It's
so
like
that's
it's kind
that's
of
during
Hollywood-esque almost. Yeah.
yeah, that's during his field expeditions into Mongolia uh
Okay,
at
yeah.
that time.
Uh-huh.
But he is a lot more than your archetypal adventurer, funny enough. He is
Yeah.
so he grew up basically a child of war
Uh-huh.
in Soviet Russia and eventually ended up going to school for geology. Um, and for some amount of time, he was essentially like helping run geological mapping expeditions on boats. So there's this photo of him that he looks like Captain Ahab or something like
Uh-huh.
that from Moby Dick, like this
Uh-huh.
full sailor's outfit.
Uh-huh.
Um, and on top of that, eventually he ends up going into paleontology through a professor of his and is incredibly like hard hitting. Like there
Mm-hmm.
are many species named after him
Yeah.
uh, because during his PhD, this is during his PhD, he's not even a professor by this point.
Uh-huh.
Uh, he names taphonomy. He
Right.
puts the name on the field.
An entire scientific field just
He basically says,
coined it.
"Look,
Yeah.
people have like kind of talked around this issue, and I'm gonna put a name on it."
Uh-huh.
Uh, and he coins taphonomy. Taphonomy, he says, is essentially the study of what happens to organisms after they die. What
Mm-hmm.
is the process, or what are the processes that lead us to acquiring the fossil record?
Right.
And he names it taphonomy, tapho, as in so it's weird. The translation is interesting.
Uh-huh.
Uh, it translates directly as the word burial.
Right. Okay.
Um, Now taphonomy has way like there's a bunch of taphonomic stuff that happens post burial, but
Definitely.
he's
Yeah.
he's thinking of burying. But I don't know if he knew this or not, if this was
Mm-hmm.
intentional. Knowing the kind of person he was, I'll get to that in a second. It may have been intentional.
Hmm.
The actual route that he used was not the act of burying something.
Uh-huh.
It is burial as in grave, as in a
Okay.
human grave.
Uh-huh.
Um, so what I find fascinating is that you can call taphonomy and be completely correct, the laws of the grave.
Uh-huh.
It is like he's talking about the burial site of any given organism, the grave of any given organism, which I
Gotcha.
find fascinating from an etymological standpoint.
Yeah.
Um,
Diagonal here in the chat says cenotaph comes from the same root word, and
yes,
that makes a lot
yeah,
of sense. Yeah.
right,
Yeah.
right, exactly. And so what I also find interesting about this guy is that he was not only a prolific scientist, he
Mm-hmm.
was also a prolific author.
Right.
He is
Yeah.
one of the founding authors of the sci-fi genre.
Huh. Interesting.
And there were some of his books that were banned in Russia at the time
Uh-huh.
because they were seen as like anti-Russia. I'm sure, had a very complex and interesting relationship with the country he lived in. But
Uh-huh.
uh, on top of that, it some of those books became very popular elsewhere, including in the US, where
Mm-hmm.
they were picked up by such people as George Lucas pre-Star Wars.
So the
And
founder of taphonomy had an influence on George Lucas, who went on to make Star Wars.
Legitimately, yes. There are some people that
I did
argue
not
that
know that. Wow.
certain aspects of his books made it into like naming conventions and things like that in Star Wars. So
Interesting.
fascinating human being.
Uh-huh.
I'm surprised he doesn't get brought up more as one
Right,
of the
yeah.
classic paleontologists because
Mm-hmm.
this guy was kind of a Renaissance man. He did all sorts of stuff.
Right. Is there a
And
biography
yeah.
on him that is well known or anything? Because
I
I've
haven't
not seen
read,
anything
yeah,
anywhere, you
I
know?
haven't seen one. I have
Mm-hmm.
mostly been picking up on things from various bits and pieces I've read.
Right.
If anyone knows of a good or a
Yeah,
biography,
please tell us.
I would
Shoot.
love to read it.
Uh-huh.
Because he's just fascinating human being.
Mm-hmm.
Anyway, so that's sort of where it started. That's the earliest time that the word taphonomy comes up. Certainly, other researchers had started to get at it a little bit before
Mm-hmm.
him,
Sure.
uh, but he was the person who put the name on it. And
Right.
after that, the field of taphonomy grew immensely. It started with him, and you get really famous scientists like Kay Baronsmeier
Mm-hmm.
and Sue Kidwell and a bunch of other people like that who are still around today,
Mm-hmm.
that in what is already a young field, taphonomy is even younger. Taphonomy is sort of almost one of the up and coming parts of paleontology in general, which is
Mm-hmm.
fascinating to me. Um, and so to back up, taphonomy itself now in the modern day is kind of defined as anything that happens, like all the processes that happen from the point that a critter keels over and dies,
Uh-huh.
all the way to the point that we pull it out of the ground.
Right.
Some people actually even argue, and I kind of agree,
In
that
collections as well, like
yes, the
fossil prep and everything else. Yeah.
fossil prep, collection bias
Uh-huh.
would be part of that. Anything that basically influences what is getting into our data sets
Right.
can
Yeah.
be, whether or not you consider it a taphonomic process in the way that sorting or burial or
Uh-huh.
post-depositional processes are, people go back and forth a little bit about. But
Uh-huh.
they certainly are part of the pipeline. I don't think
Interesting. Yeah.
anyone disagrees on that front. It's
Yeah.
just whether, like, is this a separate thing? Should we call it part of
Right.
taphonomy?
Do
That
they have to
I
be
don't have.
natural processes, or can it
Right,
be
right.
something that a person does?
Yeah,
Is it
I
a
don't
desk
have.
projection from a journal editor? Is that part of the taphonomic
Right,
process? You know?
right. Yeah,
Yeah.
I don't have too much skin in that game, but
Yeah.
it's important to know that there's, including human processes,
Uh-huh.
a bunch of different processes that can affect what data makes it into our data sets that we use to
Right.
understand ancient ecosystems.
Uh-huh.
So that can include anything from, when you first start, the first thing that happens immediately
Mm-hmm.
is that, and for any organism,
Mm-hmm.
decay is a given.
Right. Yeah.
There is not a single fossil out there that did not experience some level of decay. Even if it
Exactly.
was minimal
Mm-hmm.
before it was buried,
Yeah.
decay is going to happen. Even like for vertebrates, we have a microbiome inside of us
Mm-hmm.
that the moment we die
It starts to
kicks
eat
into
us.
high gear. Yeah, it starts to
Yeah.
eat us.
Yeah.
So decay is a massively important one. You've got things like scavenging from other animals, and
Mm-hmm.
heck, plants and fungi as well, outside forces, right? Outside biological forces.
Yep.
There are external physical forces that can happen. That's where a lot of my realm is.
Mm-hmm.
Things like the movement of carcasses after they have died,
Uh-huh.
via water or wind, or technically other animals could also just drag a carcass somewhere.
Sure. Yeah.
Um, Lots of different physical things that can happen to an object,
Mm-hmm.
or to a carcass as an object. There are chemical things that can happen. Things like if you have a skeleton laying out on the landscape, you have sun bleaching and things like that. You have
Yep.
the chemical forces from groundwater, chemical forces
Soil
happening,
acidity, things like
soil
that. Yeah.
acidity, all of these
Yeah.
different things that have big impacts on how much of a carcass survives.
Mm-hmm.
And all of that continues over this sort of hazy, blurry line that is burial, because burial is not necessarily permanent the moment it
Right.
happens. Things can be
Yeah.
buried and then exhumed and buried and exhumed multiple times.
Reworked, as we say. Yeah. Yeah.
Right.
Mm-hmm.
And, if a carcass is buried 2 feet in the ground, a lot of the surface processes still have a hold on it. So it's hard
Oh
to
yeah.
say exactly when you pass the threshold of where those forces stop.
Mm-hmm.
But eventually, new forces do take hold. Things like groundwater chemistry deeper in the earth, things that
Mm-hmm.
start to convert minerals that are part of a living organism into, you know, rock and
Mm-hmm.
various different things that we find in fossils. And those happen to different degrees in different places. There are some places where most of the minerals are straight up just leached out by groundwater,
Right.
whereas other times it's more that they're transformed from one state to another. Um, and you can have tectonic forces. You can have, the movement of continents
Right.
subducting fossils and destroying them. You can, there are so many different possibilities.
I saw a cool
I,
example of a.
yeah.
Sorry to interrupt real quick, but
No,
saw
yeah.
an example of a leatherback turtle fossil. I think from shoot, where was this? I think the Central Valley of California, and there's a fault going right through the carapace.
Oh, right. Yeah,
So it's just
exactly. Exactly.
bonkers, you know? Like
Yeah,
these are
there
the sorts of
are,
things that you have to be able to pick out what is a taphonomic force and what is actual morphology, the shape, the biology of the organism. You've got to be able
right.
to
You
pull these
can,
different things apart to know what's what. So
for
yeah.
instance, you think about lake deposits in which you get these beautifully preserved specimens like Archaeopteryx and various other things like that. And
Mm-hmm.
almost all of those are pancaked.
Yep.
They
Yeah.
are flattened in a way that some other fossils aren't, and that is a
Mm-hmm.
taphonomic bias that is imparted on those remains. And then eventually you have the getting it, first of all, being lucky enough to be exposed for people to see,
Right.
and
Yeah.
then the excavation and whatnot, everything that happens post
Mm-hmm.
re-exposure. So there are multiple stages of taphonomic processes that different taphonomists tend to study.
Mm-hmm.
And I like to think of it all as, because it is one continuous set of processes. I like to think of it as sort of a choose your own adventure to a degree,
Uh-huh.
in which 99.9% of the endings are the bad ones.
Yeah.
I don't know if that's aging me, the Choose Your Own Adventure books.
No, I think people in chat can relate to that for sure. Yeah.
I'm hoping people still read those. Um,
Yeah.
I grew up on them in school, and you know, these are books where you're like basically telling your own story by picking what actions you're gonna do. The book will say flip to whatever page to see what
Uh-huh.
happens next. Um, and so you can imagine that from the moment an animal keels over and dies, or any other organism, taphonomy applies to everything, that you set off basically a timer for a bunch of series of processes that can start acting on it.
Mm-hmm.
And the results of those processes lead to either the thing surviving or it not surviving. And
Mm-hmm.
that happens over and over and over and over again through an almost infinite spread. If you viewed it as a tree, like it's a decision tree, just
Right.
this insane spread where the vast majority of the tips of that tree are your fossil is destroyed. There is
Mm-hmm.
no
Game
trace of it
over.
left.
Yeah. Yeah.
So,
I'm
yeah.
here responding to some things in chat too. We've got Joshua Knupe, a Paleo stream here in the chat, and he says
Oh, hey,
hi.
Josh.
Says Michael, you are not old enough to talk about does this age me?
I don't, I
Uh,
mean, listen, there might be people in the chat who don't read
oh
those
yeah, no
books
for
anymore.
sure.
I don't
Yeah, I'm
know.
sure there's got to be like a modern video game equivalent of that though
I
that
guess
I'm
it'd
not
be
aware
like
of. Yeah.
it would be like oh gosh. What
There
are
was that game that
the
was really popular like just a few weeks ago, right? The superhero emergency dispatch. It's called Dispatch, isn't it?
this oh
Is that
okay.
kind of like that chat? Is that the
Pro,
same kind of deal?
right, or
Yeah.
the Telltale games, like those ones where you're
Okay, okay.
making decisions and that leads to different endings, that kind of thing.
Yeah. Yash confirms right there. Telltale Games. Yeah. Yeah. I
Yeah,
feel like
yeah,
such a
yeah, yeah.
boomer right now.
Right.
So
The this you know, this Tyrannosaur femur will remember that.
yeah, there you go. Yeah. Yeah.
Yeah. Anyway, so that's the generalities of what taphonomy actually entails. It is
Right.
the study of everything that happens to lead toward, or not, the vast majority of the time, not,
Uh-huh.
fossilization.
Right. Yeah. Okay. And I thank you for walking us through that again.
Yeah, of course.
So I really want to emphasize the point that taphonomy is not some arcane field of study or something like that, despite being relatively kind of new in paleontology as its own thing. But like there are taphonomic processes that we see going on every day, and people in the chat are going to see these things every day. What are some of those things that they might encounter on a daily or weekly basis? What are some different taphonomic processes that are just
Oh
around us all the
gosh.
time?
So, I mean, if you're anywhere where there is visible life,
Mm,
you have seen taphonomy at some
right,
point.
right, yeah,
Because they are just the processes that happen to dead things.
hmm
If you have seen a tree fall over and watched a log decay, you have
Uh-huh.
seen taphonomy. If you
Yeah.
have walked along a river or lake and seen fish washed up on the shore, you have
Yep.
seen taphonomy.
Mm-hmm.
If you have been out in the woods, like I was a lot as a kid, and found deer antlers laying out on the landscape,
Right.
because they last very well, even compared to bones sometimes.
Very
Antlers are
resilient.
just
Yeah.
very resilient. You have
Yeah.
seen taphonomy.
Uh-huh.
There are so many different processes. The most observable ones are those surface processes, the ones that actually happen, as the name would imply, on the surface of our planets.
Mm-hmm.
Those are the ones that are the easiest for us humans to see
Right.
visibly.
Uh-huh.
But if you have ever seen a dead thing ever,
Right.
you
Yeah.
have
Yeah.
you might not think to look closer at it, but if
Uh-huh.
you do, the cool thing about taphonomy to me is that more than really any other part of paleontology to me, it is the ability to track a small scale story.
Right.
It is the
Yeah.
ability to go out to the river behind my parents' house in Oklahoma, pick up a piece of what is probably deer bone, look
Uh-huh.
at it, see that it is isolated on its own. It has been moved from the rest of the skeleton by some amount. Uh,
Uh-huh.
the fact that it is in a gravel bed, the fact that it has little trails left in it from small arthropods that have been trying to chew on this bone, the
Right.
fact that it's
Yeah.
got abrasions on it from likely coyote teeth.
Uh-huh.
They're all these little things about, animal remains
Right.
that can tell you a story about what happened after this animal died.
Right. Yeah. And I can think of one example off the top of my head where a misunderstanding of taphonomy maybe leads to some wild stories. I'm thinking of like all these stories about chupacabra, you know, mutilations of cattle or blah blah blah. The eyes are
Yeah,
missing. What's up with that? Well, that's one of the softest parts of the organism. It's one of the most palatable to scavengers. Of course, that part is going to be gone within an hour or something, right? I
yep,
mean,
yep, absolutely.
yeah, yeah. When we're talking about taphonomy in the fossil record, um, I want to emphasize that this is not like unlike in a video game, it's not like this like rigid set of things that happen all in the same sequence and all in the same to the same severity or whatever. It can vary really wildly, right? So give us maybe a couple examples of uh surprising bits of preservation or taphonomy from the fossil record and how we can start to understand those maybe. You mentioned Archaeopteryx earlier, which I've got up on my wall right there. Um
Yeah,
yeah, yeah.
so I would say that at the step one,
Mhm.
the thing that is going to influence what happens to your organism. I'm going to keep calling it an animal, but keep in mind that this can be any organism.
Okay.
But whatever critter you've got, the environment in which they died is going to have a massive influence on whatever happens next.
Gotcha.
Because
Yeah.
if you're let's take Archaeopteryx. Let's take a small flighted theropod verging on birds,
Mhm.
a little birdie guy.
Uh-huh.
Um, oh, hello.
Sorry. That's Sweetie Pie
Cat.
right there. Yeah. Ignore her.
Uh, no, I'm watching for the chat to go nuts because that's probably exactly what will
Oh,
happen
they're
the
used to
moment
it
a
at this point.
cat
There's
up.
yeah.
Oh, I see. Um,
Regular occurrence here. It's like clockwork.
regular occurrence.
Yeah.
Yeah, so if we start with a small bird type or bird line theropod like that,
Uh-huh.
and we have it die, in the area of, let's say, just a typical river flood,
Yeah.
typical river floodplain.
Uh-huh.
Um, Oftentimes in those kinds of environments, we don't find whole articulated, beautiful small theropods
Right.
because there are a series of processes that happen
Right.
that
Yeah.
tend not to favor that.
Yeah.
As opposed to if it dies in the area of an anoxic lagoon, a lagoon in
Right.
which there is, a uh, or a area of deep water in which there is low. high salt content, low oxygen content,
Right. So you can't
then
get scavengers coming in
right,
there
you
to
don't get you
eat
don't get
everything up. Yeah.
scavengers. You
Yeah.
don't get a lot of movement because there's not that much flowing water. It can't be transported out very easily unless it's floating.
Right.
Um,
Yeah. And you don't even
there
get that much
are
decay from like aerobic decomposers, right? So like if there are
exactly because you
bacteria or
are
other little
out of their
organisms like that,
range.
yeah, yeah, yeah. Okay.
Exactly. So, or let's put it in a cave. People
Hmm.
don't think about caves that much, but caves in the
Right.
fossil record, if you're thinking, especially outside the Mesozoic,
Uh-huh.
in the more recent, let's think Cenozoic and forward, there are caves in the Mesozoic and they preserve great stuff. Same in,
Hmm.
actually, there's one in the Permian even. But
Interesting. Okay.
especially for the Cenozoic,
Uh-huh.
caves are incredible at preserving organic material.
Huh.
Um, Mainly because there influx of sediment into caves and things like that, that it makes it
Gotcha.
very easy to bury things in there with a
Okay,
low
okay.
amount of scavenger input.
Uh-huh. That makes a lot of sense. Would stable temperature have something to do with that too, or is that
Stable,
kind of a red herring?
absolutely. Stable
Okay.
temperature helps a lot.
Uh-huh.
There is, there are certainly things living in caves,
Mm-hmm.
and that kind of thing, but there is often less scavenging going on than there would
Right.
be outside.
Mm-hmm.
Um, and like I said, often there is sediment coming into caves
Right.
that is
Yeah.
helping to preserve things as well.
Uh-huh.
So it's isolated, right? It's isolated from the outside world, and that often can make it very, very good at keeping things around for long durations of time.
Makes sense. Yeah.
That
Yeah.
and the sediment itself is often not extremely heavily disturbed,
Uh-huh.
which means that you can have a very good look at the small scale stratigraphy of what was happening in this cave over thousands of years.
Right. Yeah.
So,
Okay.
yeah, overall, the main thing that's going to impact where the decision tree goes, what possible paths there are,
Mm-hmm.
is going to be your depositional environment to start
Mm-hmm.
with. And from there,
Makes
then things
yeah.
can get very complex very quickly. But
No, that makes a ton of sense. Yeah. Um, Speaking of the importance of taphonomy, uh, I'll put you on the spot a little bit here. Can you think of any examples of when a paleontologist's lack of attention to taphonomy kind of led them astray with their research? Are there any big gaffes or blunders when
oh
somebody
gosh,
failed to take taphonomy into account?
plenty. Um,
Not to, we're
I
not trying to
think,
disparage anybody,
yeah.
obviously, chap,
Well,
but
I'll go with a general practice,
okay,
actually.
yeah, yeah.
Um, Footprints.
Mm,
Trackways are not organisms, but are subject to their own set of taphonomic variables
right.
that can occur that are mostly geological,
Uh-huh.
uh, that can impact how well they're preserved.
Mm-hmm.
Part of that taphonomy is actually the animal itself and how it is moving and what it is moving on, what the
Uh-huh.
sediment it is preserved in is. Um, so there are, or have been, I think it's less common now. People are starting to kind of wake up to this idea that uh, you can't always reliably scale an animal off of its footprints
Right.
because when an animal is moving over a substrate, what substrate they are moving over is extremely important to what trace they will leave behind.
Right.
So if
You
you
can leave a larger
have
footprint if you have
exactly
softer sediment, or if you're a heavier animal, or moving at a greater speed with greater force. The
right,
impact that you leave might be larger. Things like this.
right, or if you're preserving it very, very well and
Uh
you
huh.
preserve, say, integument, like integumentary
Yeah.
traces,
Uh huh.
those
Skin
integumentary
impressions.
traces are subject to what happens when you press that skin into mud.
Right.
For instance, on sauropod trackways I've seen with integument on them in Argentina,
Mm-hmm.
uh, what you see is not little scales,
Mm-hmm.
or at least you shouldn't assume that this is what the scales look like. You
Mm-hmm.
see rake marks. right?
Right. Yeah.
And you do not know that that was the size of the scales because
Right.
those are not the scales. Those are the
Right.
rake marks that the scales leave when you press them into a substrate.
Uh-huh.
And I have
So they
seen researchers both on the integumentary side and on the like animal size side, taking very precise measurements of like, oh, this animal was exactly this long, or the scales were exactly this size and this shape.
right, right. Uh-huh.
But that's not necessarily the data we have. We have the data of what happens when you press an animal-shaped object into mud.
Mm-hmm.
So that would be a general practice that I see sometimes. Another would be when you have extremely well preserved organisms,
Mm-hmm.
people will take them at face value and assume that what they are looking at is representative of what the animal actually looked like.
Right.
But like I said at the beginning, I don't care how pretty the fossil looks. Every single fossil that has ever been preserved has
Mm-hmm.
been subject to some level of decay.
Right.
That is a given. Decay is inevitable.
Mm-hmm.
And so if you look at the either in three dimensions or two, whether
Mm-hmm.
it's a quote unquote mummy, like some, animals you'll find, whether that be like the Siberian Ice Age stuff, or older in time, say the quote unquote dinosaur mummies, they're not actually mummies, but you know what I mean. The
Sure.
mummies that you find in the fossil record,
Mm-hmm.
you cannot assume that just because it looks like a certain thing on a mummy, it does not like necessarily mean that that animal looked one for one exactly like how you found it. There is some work you need to do on, okay, what happened to this animal in order to preserve as well as it did that also led to these things happening. The way the skin folds over the neck or whatever,
Mm-hmm.
that isn't necessarily something you can just copy into like paleo art or what have you,
Right. Yeah.
because that is potentially a result of desiccation and things like
Right.
that.
Maybe shrank in size. It's, yeah, I can see that for sure. Yeah.
Yeah, and that's not just in dino stuff. This is something that I've seen even in the invertebrate literature for like flattened organisms. People will look at a an organism and say, "Well, this is exactly what it looked like because it's pretty." There was a
Gotcha. Yeah.
paper. There was
Yeah.
a paper that said something to the effect of you can assume that a structure is preserved in a fossil if the evidence is compelling, which in that sense, compelling kind of just means it looks pretty and it kind of looks like the
Did it
thing you
look
want it
good?
to look
Yeah.
like.
Uh-huh.
So
Interesting.
there's a level of you absolutely have to take into account, even if it's
Right.
pretty, even if it's a beautiful fossil, which there are
Uh-huh.
many of, you
Mm-hmm.
have to take into account what happened to make it that pretty that might have resulted in certain biases, even in a very nice specimen.
Right. Interesting. Now that makes a lot of sense. And then I think back to when lack of information and maybe like a maybe ignoring taphonomy a little bit led to major misinterpretations of phylogeny. Like back during the debates of bird origins, there was this idea that well birds couldn't have evolved from theropod dinosaurs because theropods didn't have a wishbone, they didn't even have clavicles at all,
Right.
and that's just a taphonomic process. Those bones were lost or maybe misidentified. And so for the better part of a century, a lot of people thought, well, birds can't have come from dinosaurs because they don't have wishbones. It it took like really obvious wishbones being discovered to overturn that idea. Um,
And what you
People assuming that the
just,
fossils are
yeah.
more complete than they are.
And
Yeah.
what you just said is one
Mm-hmm.
of the more broadly important reasons that taphonomy exists.
Right. Yeah.
Um, my experience of taphonomy so far as a researcher is on a relatively restricted scale. I'm looking at things that happen on local scales that influence how fossil sites individually form. And that
Right.
is one way
Yeah.
that paleontology is important. It can be useful for understanding like local ecology and things like that.
Uh-huh.
But when you zoom out, The fossil record, I will repeat it again because it's important, is the data that we have to go off of to study anything in paleontology. It is the
Right.
only data we have.
Mm-hmm.
And if we don't have a full understanding of the biases that underlie that data, we are going to make misinterpretations in other parts of paleontology. Things
Amen.
like phylogeny, for instance. If you are
Yeah.
not regularly preserving a bone, you don't
Mm-hmm.
have the characters that that bone imparts onto phylogeny that tell you what part of the phylogeny that animal might have sat in.
Right. Yeah.
For instance, if again, I'm going to go back to birds, but in birds, um, if you go into the bird fossil record, a vast amount of their fossils in
Uh-huh.
most environments that are not the pretty ones, you find tarsometatarsals. That is what you find.
Yep. It's like the most
Uh,
robust part of the organism usually.
yep.
And
And
yeah.
luckily,
Yeah.
tarsometatarsal or tarsometatarsai are actually fairly decent in terms of characters. Like you
Pretty
can get a
diagnostic.
lot
Yeah.
off of
Mm-hmm.
those, but you don't have skulls a lot of the
Right.
time. You don't often have other, like, you don't always have vertebrae. You don't always have a lot of these other more sensitive parts of the skeleton that could
Mm-hmm.
tell you a lot more about that bird's phylogeny than if you just have tarsometatarsai.
Right.
So there are really important large scale biases at play, even beyond something like phylogeny. Let's zoom back even further. Broad scale depositional environments. I study rivers and floodplains because they are where fossils are common on
Right.
land, right?
Uh-huh. It's almost like the old adage of looking for your car keys under the streetlight or something.
Right, right. There are on the darkened street of Earth history, there are streetlights that show us what certain areas of the planet were like,
Uh-huh.
and then a bunch of dark area that we are rarely going to get a look into
Mm-hmm.
because we're relying on like the ambient light from the moon or whatever,
Right. Yeah.
in which either our
I
preservation
like this analogy.
is either
Yeah.
very bad or preservation
Mm-hmm.
or not at all.
Right.
Most upland areas we have relatively poor understanding of in Earth history because
There's no deposition.
that's not where sediment deposits.
Yeah,
It
exactly.
goes
Yeah.
away from those areas in most
Mm-hmm.
cases. There are some extreme, like out of the way, whoa, this is interesting areas where you will get an upland area preserved,
Mm-hmm.
because of a trick of luck. But in general, there are taphonomic biases that are influencing, the broadest level of like, where do we have fossils from? Like,
Right.
what parts of the world at what times are we using to understand the way that life has evolved?
Mm-hmm.
Because we might be missing really important sections that we might never have a good
Sure.
understanding of. And that is okay as
Mm-hmm.
long as we understand that, as long as in our research that we're doing, we check our own biases on, what we have to run the research that we want to run.
Right. Well said. Yeah.
So,
Let's get into
yeah.
the specifics of your work a little bit.
Sure, yeah.
Maybe for those of you, or for the members of chat who were not here for the video earlier that you produced, tell us about this project that you just published. Give us an overview of the paper, and then maybe we'll get into how this came about in the first place.
Yeah, yeah. Okay, so what I just published before getting into like how it happened
Mm-hmm.
is a paper in the journal Paleobiology about the transport and burial of vertebrate bones
Mm-hmm.
in overbank floods, in sheet floods. Um, these generally shallow water but somewhat intense water flows that happen outside of river channels.
Mm-hmm.
Um, and we basically looked experimentally at how this happens. We physically put bones into a very large flume, which I will wait on defining because I think we're going to get to that.
Yeah.
Uh, we experimentally tested how bones move, sort, and bury in these particular kinds of water flows, basically.
Hmm.
Um, yeah, so that's the generalities of it. That's in the journal Paleobiology. And
I
that
just
was
put a
just
link in the chat too
published.
if anybody wants to check that out. Yeah,
Awesome, yeah. You'll
yeah,
see we had some fun with the names for obvious reasons.
yeah.
Um,
It's really cool. Yeah.
so yeah,
um.
that's the generalities of that project. That
Uh-huh.
was just published on Monday.
Right. Yeah. Um. Yeah. How did this come about? What prompted you to investigate this in the first place?
Yeah, so let's flash back about 4 years.
Hmm.
Um, I got done with my undergrad at UT Austin in Austin, Texas. Hook 'em
Hmm.
horns. And I was a geology student who was doing a lot of work on the evolution of bird vocalization. Uh, I was essentially doing a biology project, which also got published and was a lot of fun to do. I really enjoyed that project.
Very cool stuff. Yeah. We've
Um,
we've looked at that before on stream. It's pretty stellar. Yeah.
Thank you. But yeah, so I got done with that and was talking with my then advisor, Julia Clark, about what I wanted to do next.
Hmm.
And I was fairly certain I wanted to go into grad school because I wanted to continue on some degree of an academic route. I didn't know how far yet, but I wanted to keep doing research because that was something I really enjoyed. Um, and she routed me to Dr. Pete McAvicky, who is my current advisor at UMN.
Hmm.
Uh, and he, if you've heard his name before, you have probably heard it associated with dinosaurs. And
Yep.
so you will probably be confused why I ended up doing a taphonomy project with him. Um, and it is because at the University of Minnesota, we have access to this really phenomenal facility called St. Anthony Falls Laboratory. St.
Hmm.
Anthony Falls Laboratory is on the banks of the Mississippi River, and it is a fluid dynamics lab, really, is the best thing that I can kind of condense it down to. Both water and air. They also have a wind tunnel.
Oh, cool. I didn't know
I did
that.
not include that in the video, but they do have a
Yeah.
wind tunnel upstairs.
Neat. Yeah.
It is NASA for fluids. Like it is
Uh-huh.
since 1936, I believe, was when it was made during
The
gosh,
WPA, Works Progress
WPA. Yeah,
Administration.
that's what it
Yeah,
was.
yeah.
WPA.
Uh-huh.
I was trying to remember if it wasn't the CCC. It was WPA
Uh-huh.
that did that. Which, funnily enough, also had a lot of influence at UT Austin's paleo program. So it was sort
Nice,
of
yeah.
an old friend to come back to. Um,
That's awesome. Yeah.
and yeah, so they built this place to be able to study, especially how water, but also air works,
Hmm.
how objects interact with it, how it moves, how it, functions on the surface of our planet.
Right.
And Pete had this idea along with one of my other co-authors, Ray Rogers,
Hmm.
who is over in McAllister
Yeah, we know Ray. He's
College.
been on the stream before out in
Oh,
Wyoming.
amazing.
He's come out and done field work with us. Yeah. Yeah,
Okay,
Ray's a
then
great guy.
y'all amazing. Y'all know Ray then. Ray's great. We
Yeah.
love Ray. Um, those two kind of had this idea that wouldn't it be cool to run some experimental trials with bones at this facility, considering that we had this, available to us.
Uh-huh.
Um, and when I first went over there, we weren't sure exactly what, questions we were going to go after yet.
Uh-huh.
But certainly, SAFL, St. Anthony Falls Lab, was really excited to have this very atypical group coming through the lab. Most of the people who work there are engineers or
Right.
sometimes geologists, sometimes ecologists. There's a broad group of people that do work there, but paleontologists are not usually one of them.
Right.
Um, so there was a lot of excitement, but we weren't sure exactly where to go with it. And Ray actually put forward the idea of what if we looked at what happens to water or bones that encounter water flow outside of river channels?
Hmm.
Because certainly a fair amount of work has been looked at with regards to bones in channels in
Uh-huh.
steady state flow. Um, but not as much work has been done outside of channels, even though in the fossil record we do often attribute certain fossil deposits to being from floods,
Gotcha.
right?
So what we're talking about is, outside of actually being in a river, oftentimes the fossils that we find are from out on the landscape, maybe on a flood plain, and they'll
Right.
only get covered by sediment if you have a huge influx of water. The river overflows its banks, dumps sediment onto them, that kind of thing. And so that's been understudied up until this point, you're saying?
Yes, very understudied. Even
Gotcha.
even though we like attribute it to the fossil record often because we look at the
Yeah.
geology and say this doesn't look like a channel deposit, this looks like a floodplain deposit of some kind.
Yeah, yeah.
Therefore, the likely deposition of sediment in a big pulse is going to be a flood.
Right.
Um,
Yeah.
so we had sort of a on the ground field understanding, but we didn't have a mechanistic theoretical understanding of how these things work.
Gotcha. Yeah, yeah.
We had the result, but we didn't have the how.
Mm-hmm.
Um, and so that was what we ended up trying to do.
Mm-hmm.
Now, that was hard because St. Anthony Falls Lab has a bunch of flumes, which I'll go ahead and define now. A
Mm-hmm.
flume is essentially a artificial river or stream channel through
Gotcha. Yeah.
which water can be controlled
Uh-huh.
at a rate that you are looking to try to put water through there.
Right. By
Um,
way of analogy, it's kind of like a log flume ride at a theme park or something like that, where they've made an artificial
yeah,
river and you're setting stuff down it like that.
yeah,
Um,
yeah.
yeah,
Except
except
that
this
in
is
this
indoors and in
case,
a scientific setting. Yeah.
right, it's indoors, and importantly, you can control what is happening. That is,
Right.
otherwise, we would just go out to real rivers and dump bones in and call it good.
Right. Yeah.
But you can't control what is going on in a real river. This is a controlled setting.
Yeah, yeah.
Um,
Yeah.
and so those kinds of flumes are usually not built to make floods.
Right. Yeah. So how did you do
Generally,
that?
that's
Yeah. Like
so the
what was the
channel
what
we
was the trick?
operated, yeah, the channel we operated in was the main channel, we call it, which is this massive flume, the biggest one I've ever seen. There
Right.
may be bigger in the world now, but it's certainly one of the biggest.
Huh.
That is 3 meter wide, 80 meter long. If you watched the video, you saw how big this thing was. I
Oh yeah.
walked around in this channel a lot.
Uh-huh.
And in fact, I just did today when I was there earlier. Um, and the cool thing about this channel is that it is so large that you can operate pretty much one-to-one scale experiments in there.
Right.
Like you can
Yeah.
put real bones in there and
Mm-hmm.
not have to use small scale models.
Uh-huh.
We did ultimately use some models, but you don't necessarily have to in that environment.
Mm-hmm.
Uh, and it connects directly to the Mississippi River outside.
That's so cool.
Um,
Yeah.
and so the way it works is that you open a head gate and the
Uh-huh.
river pours into the building
Uh-huh.
and then out the other side.
Uh-huh.
Um, so what we did in order to make a pulse of water was to open the gate and shut it again.
Mm. Okay.
And that made just a pulse of water come through.
Gotcha. Yeah. Yeah. So not a continuous flow, but just like a stochastic burst, essentially, which kind of
Exactly. Yeah.
mimics what a flood would be like rather than like being in a river itself.
Right. Now,
Yeah.
controlling that was easier said than done,
I can imagine. Yeah.
because we kind of just had to hold the button on the gate open
Uh-huh.
for like exactly 11 seconds.
Uh-huh.
Otherwise, you would, because we were trying to be reproducible. We didn't only make one flood, we had 5 or 10, depending on what we were running, of each like level of flood that we were doing. Because we did a
Right.
low discharge and a high discharge flood.
Uh-huh.
For each of those, depending on the set of bones that we were running, we either wanted to do that 10 times or 5 times each.
Nice.
And
Yeah.
it ended up being several hundred experiments, if I recall correctly.
Shoot.
Um,
Yeah.
so this
And
is
so
we wanted it to be repeatable.
right.
So you had to time that gate exactly right to get the
Uh-huh.
same flow.
Right. Yeah. And so when you repeated this a bunch of times, did you see a consistent patterns emerging here, or was it different every time?
We did see consistent patterns. I should, before I get into like heavy results, I should start with what we were actually testing.
Yeah, yeah. Let's get
Uh,
into that. Good thinking.
so, w- in order to justify what we were testing, I kind of need to explain one bit of previous literature that was in the video for those who saw it, but
Voorhees, right? Yeah,
Voorhees. So
yeah. Which we have here up on our
this,
wall today. I think this is from one of your papers, actually.
oh no,
The
wait, really? What?
1969 figure. Yeah. I printed
That's
that just for today. You know, we
Oh,
changed the
that's
background
wild.
out every day. Yeah.
Yeah, that's wild. That's the version I made for the paper. That's funny.
It is. Yeah. Yeah.
Uh, funny.
It's a good figure. Well
Um,
done. Yeah.
Thank you.
Yeah.
Yeah, so what those are is they come from not the hadrosaur one, but the sheep one specifically. The
Yeah.
hadrosaur one came later.
Hmm.
The sheep one comes from Voorhees 1969. This is a thesis that was written by Voorhees for his PhD. Michael Voorhees is his name.
Hmm. Yeah.
He is also a really impactful paleontologist outside of just taphonomy. He
Yep.
is the guy who found ashfall fossil beds.
Right. Yeah. In
That's
Nebraska.
him.
Yep.
Yes, he's still around and alive. He still lives in Nebraska, not far from Ashfall. I have a lab mate who lived in his neighborhood growing up.
Uh-huh.
Um, so huge shout out to Voorhees because he was the first guy to ever think, let's physically test what happens when bones encounter water flow.
Right.
Uh,
Which
it
seems like such an
was
obvious idea, but no one had actually sat down and done that before.
No one had actually done it. No.
Yeah. Yeah.
Um, I think that is Ida in the chat. Yes, Ida, taphonomy is a Michael science. Um,
I was gonna
um,
bring that up. Yeah. I like that you're monitoring the chat as well, Michael. This is great.
I thought I'd
Yeah.
keep an eye on it.
Yeah.
Anyway, so yes. So this was not the majority of his PhD. Most of his PhD was on I believe, Miocene mammal deposit from either Nebraska or nearby.
Okay.
Um, and it happened to be a fluvial deposit, and so he wanted to look at, how can I look at sorting and transport,
Hmm.
um, because again, to I'm going to get in light jargon but not heavy jargon. Uh, One of the things that was known to be important but had never been physically tested was
Hmm.
the idea of allochthony versus autochthony.
Right.
These are terms that are stolen from the geology literature.
Uh-huh.
And I'm not going to keep saying those words because they are really similar sounding and kind of annoying.
Yeah.
Um, they make sense from like what the roots are. Allo is different and
Like
auto is
allopatric
like,
speciation. Yeah.
right,
Or
exactly. So,
allosaurus. Yeah. Yeah.
right. So what that actually means is that allochthony, or uh, a site that is found away from where an organism died,
Yeah. It implies transport.
versus,
Yeah.
right, it implies transport, whereas
Hmm.
autochthony implies that your remains have not significantly moved.
Right.
Usually, if they move like a meter, okay,
Hmm.
fine. That's basically autochthonous.
Yeah.
In order, there's a little bit of little bit of kind of technical argument that goes on between like what defines allochthony, how
Sure. Where do you draw
far
the
does
line? Yeah.
where do you draw the
Yeah.
line? And again, that's
Uh-huh.
another thing I don't have too much skin in, but
Yeah.
um suffice it to say, when Voorhees came along, it was known that this was important, but no one had ever physically tested, okay, what bones are most likely to move further than others, because
Right. Yeah.
bones are objects, they are physical objects, they are subject to physics.
Right.
Um,
As most
and
objects are. Yeah.
right, as most objects are, and the
Yeah.
size, shape, and density of them is going to change how they move.
Hmm.
Um, so he took primarily sheep and coyote bones,
Hmm.
put them into a shallow flume, and wrote a like 3-page addendum to his PhD. It's not very long.
Right.
He did not intend this to be some crazy like, landmark paper. In fact,
Right.
he never published that on its own. It's an addendum
Uh-huh.
to his PhD.
And yet it ended up
Um,
being so foundational.
right,
Yeah.
because what
Yeah.
ended up happening was he qualitatively, fully just looking at the bones and observing what they did,
Uh-huh.
basically said, okay, in these two skeletons that I've put into the flume, these bones tend to move like this, these bones tend to move like this, and these bones tend to move like this.
Right.
Skulls don't move very far, vertebrae do.
Mm-hmm.
Um, and he divided those up into three general groups, which are what you have on the wall.
Mm-hmm.
Those groups
It's right here
ended
too.
up
Yeah.
getting the name Voorhees groups in
Mm-hmm.
later papers. He didn't call them that. He was not. He
He wasn't
was.
that stuck up.
From
Yeah.
what I understand, he's a pretty humble guy. From what I
Yeah.
understand, he would not have
Yeah.
named his own groups that.
Uh-huh.
But uh, they became foundational to fluvial taphonomy as a whole.
Right.
They have been cited hundreds of times over the course of the last 50 years or so.
Mm-hmm.
Um, and so to get to the point of why I'm discussing Voorhees groups, when we went into the flash flood world, we wanted to know people have been applying Voorhees groups to any kind of flow and any kind of animal.
Right.
Can we do that? Right? Is that like, can we still do that and
Does it hold true for
expect,
like all these different critters and everything? Because everyone's
right?
assuming that it just kind of does. Yeah.
Well, and
Yeah.
importantly, not just different critters, but different kinds of water flow. Like he
Ah,
was
okay, okay.
looking, the reason we went into flooding
Uh-huh.
rather than just steady state river flow was that people looking at the fossil record have gone to sites that seem to relate to flooding and gone,
Mm-hmm.
oh, yes, let's put Voorhees groups on this.
Right.
But that's a very different kind of water flow between something that is just a steady movement of water versus
As
one
in a
where there are
river. Yeah.
bones out on a dry landscape that are then hit by water.
Right. As in
Um,
the case of a flood. Yeah.
right, right.
Yeah.
So that was why we went into this flood mindset was, well, we know that in the fossil record there are flood deposits,
Mm-hmm.
and we know that they're important and that they preserve fossils. But we don't have a sense of whether these previous methods are applicable to these places.
Right.
And in
Yeah.
addition to that, can you apply them to other animals as well?
Uh-huh.
So, one thing that we threw in was a sheep skeleton
Mm-hmm.
because that was something that Voorhees tested and was
Sure.
easily accessible. We were able to get a sheep skeleton without too much issue.
Uh-huh.
Um, and then this is where my advisor comes back around into being a dinosaur person.
Uh-huh.
Uh, the original idea was, there are these Voorhees groups that have been applied to hadrosaurs
Uh-huh. Duck
from Bell and
billed sure.
Campione, again, the other one you have on your wall,
Uh-huh.
um, that were mostly based, from what I understand, it's not super thoroughly explained in the paper, but from what I understand, we're based on how many of a given bone there are in the skeleton of an animal. So,
Okay.
like,
Yeah.
there are X number of vertebrae and X number of skulls. Well, there's one skull. There's
Uh-huh.
X numbers
Sure.
of limb bones, that kind of thing. And they used that to say these ones are going to move more easily than these ones. There's a
Huh.
little bit of, yeah, it's a little like, okay, these are not experimentally derived, which was another reason
Right.
we wanted to
Yeah.
go into that.
Mm-hmm.
So we 3D printed and weighted a set of hadrosauroid dinosaur bones. The
Right.
postcrania are all this animal called Eolambia,
Uh-huh.
because
Yep.
we have a bunch of remains of that animal in our possession
Uh-huh.
that we were able to. They came from the Field Museum originally. I think Pete's actually returning that loan to yesterday, I think.
Nice.
Um,
So you scanned those and 3D printed them.
so we scanned those and 3D printed them. We don't
Nice.
have a good skull, so we
Uh-huh.
went to the Canadian Museum of Nature and were able
Mm-hmm.
to get a skull scan, both of individual skull bones and of the
Mm-hmm.
whole thing, for Edmontosaurus regalis.
Right. I think I
Um,
may have printed that same file life size about a
you
year and a half
may
ago.
you may have, yeah. They were very cool with just being like, yeah, absolutely, you can print this many of them,
Yeah, that's awesome.
go wild.
Uh-huh.
And the thing that was interesting, like the reason that we got both a whole skull and pieces of a skull,
Mm-hmm.
is that it's another thing that Voorhees groups don't take into account.
Right, because he was working with mammals who
Non,
their skulls
right.
tend to be a bit more I don't know. They don't have all these beautiful fenestrae and windows in them like dinosaur skulls do. Dinosaur skulls tend to
Well,
disarticulate
that's
afterward.
the main thing, yeah, is that
Yeah.
not just dinosaur skulls, but reptile skulls as a whole
Yep.
tend to disarticulate very easily.
Mm-hmm.
They don't fuse nearly as much as mammal skulls.
Yeah.
And
Yeah.
so that had never been looked at, uh, not directly anyway. So we said, okay, let's get both an articulated skull and pieces of a skull and see how they move relative to each other. Like, are there quote unquote Voorhees groups in the skull of an animal
Right.
that
Yeah.
appear?
Uh-huh.
Um, and so that is both the setting and what we were testing with.
Mm-hmm.
We were setting in a one-to-one scale, essentially, uh, large channel through which we could run flash floods, really
Mm-hmm.
shallow sheet floods. Nothing
Right.
really, really deep. We're not talking like, on the order of, say, the floods that happened in like Texas this year, though those were
Oh
quite
yeah. Ooh.
large.
Yeah.
These are more supposed to be representative of a typical overbank flow that
Mm-hmm.
you might see commonly in the fossil record.
Gotcha. So
One
if
of the
you
things
get
we
a
were
lot of
thinking
rain and then
about, yeah,
a river just kind of barely overflows its banks, and you get maybe a few
right,
centimeters of water going onto the landscape, that kind of thing. Okay.
exactly,
Gotcha.
yeah.
Yeah.
Um, and I think maximum we had about 10 centimeters of water or so.
Okay. Nice. Yeah.
So like a reasonable flood. It's,
Yeah. Yeah.
not the kind that would flip a car over, but a
Right.
reasonable flood.
Uh-huh.
Um, and it turns out that looking in the literature, actually a lot of floods are on that scale. They are on the
Mm.
lower, the low, still intense, but lower flow scales than the really exaggerated ones. On that scale,
Gotcha.
you can imagine that basically any animal is gonna just go, right?
Yeah.
There's
Yeah.
not a lot to test there.
Yeah.
Um, so that's the setting. And then our animals, we've got a sheep and a hadrosaur.
Mm-hmm.
Sort of a generalized hadrosaur, right? We've got an Eolambia
Right.
and the skull of a Monosaurus. Importantly, when we printed out that material, we did not print it at full adult size. We printed it intentionally at the scale of the sheep.
Oh, so you're scaling each of the individual bones to be roughly equivalent to the femur is the same length as the sheep femur and
It,
etc. like that?
so yes, the sheep femur was, or the hadrosaur femur was the same size as the sheep femur, and then we
Okay.
scaled all the other elements relative to that hadrosaur femur.
Oh, okay, gotcha. Yeah. Interesting.
And the reason for that was that we wanted an animal that was in the same size range as the sheep.
Right.
Turns
Uh-huh.
out, actually, a lot of our juvenile Eolambia are already about that size.
Uh-huh.
Um, so it is full scale for a juvenile.
Yeah, yeah.
Uh, but their underlying reason, and one of the main experimental things that I think, because paleontology is not always considered a very experimental field, like we don't do a lot of direct
Right.
physical experiments. We might not, like a paleontologist might not think this way, but it is important to think about.
Yeah.
In an experiment, you are not trying to replicate reality. You
Hmm.
are trying to get at the underlying processes that drive reality.
Right.
And so, what we wanted to do, like the reason that we scaled it to that size, was to see whether the shape of the bones significantly influenced how they moved relative to the sheep.
Right.
Because
Yeah, yeah.
certainly, yes, a full size hadrosaur femur is probably going to move differently than a sheep femur. That's
Definitely. By
okay,
virtue of its
great.
size and mass. Yeah.
Right.
Yeah.
But
Yeah.
the thing that was really important to know was, is the shape of a hadrosaur femur sufficiently different that you
Right.
would get different results from a sheep? And
Uh-huh. But
repeat, rinse and repeat for every bone.
yeah, yeah.
Um,
Yeah.
so those are our, actual materials that we're dealing with.
Uh-huh.
Now, in terms of what we actually, getting back to your original question, what we saw, we did get coherent results. We got pretty consistent results between floods.
Uh-huh.
We did a fairly good job, not to toot my own horn, of keeping the floods pretty consistent. They were fairly replicable. We were
Nice.
able to get within a range of discharges, which discharges just the amount of water flow per area,
Hmm.
um, that were ranging for the lower floods between 140 liters per second to 170 per second.
Okay.
And then for the higher floods, between 340 liters per second up to about 370. So
Nice. Okay.
within a range of about 30 liters a second, which considering the amount of error there is on the gate,
I was
I
gonna
would
say,
say
yeah.
reasonably good. Reasonably
I would.
good.
I think that's impressive, given how kind of crude that mechanism sounds.
Yeah,
You did a really good
yeah.
job. Yeah.
It was tough,
Um.
but we got
Yeah.
there. So we had within each flow condition, we had a relatively similar sets of experiments that would happen. And the bones, certainly there was a range, and you can see it in the paper in that box plot figure.
Mm-hmm.
Uh, there is a range of distances that things can go,
Hmm.
and there are reasons for that.
Uh-huh.
But overall, if you just take the generalities, each flow condition was pretty coherent.
Gotcha.
And I think the first biggest takeaway
Uh-huh.
that we found was that for the hadrosaur,
Mm-hmm.
we could statistically uh, generally pull out something like Voorhees groups in a
Okay.
very general sense.
Mm-hmm.
However, multiple caveats. One, there was a lot of overlap. Um, each group was not a hard line. It was a very much like an overlapping thing between multiple groups.
Okay.
Um,
Okay.
Secondly, not like the composition of each group
Mm-hmm.
was not the same as the Voorhees groups. Like
So
what
different
bones
elements were fitting into each of these categories, you mean?
exactly, exactly.
Huh. Okay.
Um, which
So give
was
us some
really
examples,
interesting.
like
Uh, the
vertebrae
easiest one I
or
can,
yeah, yeah,
yeah,
go for it.
easiest one I can think of, pelvic bones.
That
In
makes a lot of
reptile
sense.
in
Yeah.
reptiles, there are three pelvic bones that are
Mm-hmm.
separate from each other.
Yeah.
In mammals, we've fused all of them together, but there are
Right.
three different ones in reptiles, and in hadrosaurs, they're pretty dinky.
Yeah.
Like the pubis is a big flat paddle,
Yep.
the ischium is a long stick, and
Mm-hmm.
the ilium is more of an actual decent, robust bone.
Right.
Um, and all three of them went easily.
Huh.
They just
Interesting.
went,
Uh-huh.
uh, which is not always the case for mammal pelvic bones.
Right. They tend to
Um,
they hold together and they might just it's in the same group as the skull, right?
I believe they're in group two, I think.
Yeah, okay, it does say group
Yeah,
2. Yeah.
group two.
Yeah.
I should note in case we use the numbers. Group one is the
Mm-hmm.
easiest to move. Group three is the least. Group
Right.
three only has the skull and the lower jaw in it. That is the only
Right.
things that are in those for group
Hmm.
for his
Big
groups.
robust elements, yeah.
Right. So we found that not only was there a lot of overlap between the groups, they also weren't made of the same bones. And then there was
Huh.
the more surprising thing.
Uh-huh.
We couldn't statistically recover Voorhees groups in the sheep.
That
We
is really
were
surprising.
completely unable to replicate Voorhees' results. Um,
And so this is not to say that Voorhees didn't know what he was doing. It's just that
no,
when
no,
you
no.
have a different kind of flow regime here, when you've got a flood rather than a constantly flowing river, it's doing different things to these bones.
Right, and here's the other reason. It
Uh-huh.
actually gets a little bit more at the philosophy behind it, almost
Okay.
more than even the results themselves.
Huh.
Voorhees groups are entirely qualitative. They are not based on numbers, they are not based on statistics, they are based on visual observation and saying this one doesn't move much and this one does. Um,
Okay.
in
Yeah.
fact, if you look at the three groups, you'll find that I lied, actually.
Huh.
Uh, on the Voorhees groups,
Uh-huh.
between the three groups, there are italicized bone names that
Right.
don't fall into any of the three groups. Uh,
Scapula, ulnar radius, phalanx, and ramus.
right. Voorhees described
Yeah.
those as bones that did not quite, that sort of exhibited behavior that was intermediate between groups.
Okay.
And so if we think about it from a physics perspective,
Uh-huh.
transportability, which is what the Voorhees groups are. They are
Yeah.
an expression of how easy it is to move an object.
Right.
It's a gradient. There are
Right.
not in nature, there are not hard lines between how easy it is to move a skull
Yep.
versus a femur.
Uh-huh.
The femur is easier to move, probably,
Yeah.
for some animals at least, and sheep
Mm-hmm.
certainly. Uh, but there isn't a hard line between them. It's a gradient.
Mm-hmm.
And Voorhees recognized that. He showed that in his chart. But
Right.
people have been using them
And not
as
realizing that. Yeah.
very hard line, differences between the bones.
Yeah.
Uh,
Yeah.
People, I talk about it in the paper a little bit, um, but people have even used them statistically and said for a fossil site, this percentage of the bones are group one, this percentage of the bones are group two, this percentage are
Right.
group three.
Uh-huh.
And that is what the method has been for 50 years, but that's just not how physics works.
Right.
Um,
Yeah.
and so our argument is that yes, the flow condition and the type of animal both did influence our results.
Mm-hmm.
Like you can't assume that you can slap Voorhees groups onto whatever you want,
Right.
whether that be depositional environment or organism involved,
Uh-huh.
and call it good. But then on top of that, there is an underlying issue even below that, that Voorhees groups themselves are
They're a
are
bit more
qual
squishy than
they're right, they're qualitative and they're
yeah.
categorical.
Uh-huh.
Those are the words that we would use, in data land. They
Right.
are qualitative in that they don't involve statistics, and they
Mm-hmm.
are categorical in that they happen in discrete categories.
Right.
Um, so we kind of make the argument, or we start to, that, hey, maybe we should be thinking about these things as more of a continuous gradient rather than hard line
There
things,
we go. Yeah. I
which
love that you said that.
is
This is something we talk about all the time on this channel is that nature doesn't like to be put in a neat, tidy little boxes oftentimes. There's
right.
lots
And
of gray
certainly,
areas, there's beautiful complexity. Yeah.
right. And certainly boxes can be useful. Boxes
Yeah.
can be
Yeah.
really, really
They help us
useful. They
understand
have,
the world for sure.
right.
Yeah.
They have been for the last 50 years, clearly, because
Mm-hmm.
they've been cited
Yeah.
hundreds of times.
Uh-huh.
But it has been 50 years, and we have the ability to try to get more at this underlying problem now than we might
Mm-hmm.
have back then. And like I said, Voorhees wrote this as a 3-page addendum to his PhD. He didn't
Right.
intend this to be the end all be all.
Right.
It's just what people have been using it as.
Uh-huh.
And so that's, if nothing else, that probably is the biggest takeaway from the paper.
Uh-huh.
And it's the thing that we're going to keep chasing, hopefully, through subsequent
Right.
publications.
Yeah, yeah.
But more specific to this flow regime, given that's what we were testing in, we found some interesting things about floods that seem to import or influence transport in ways that typical river flow might not.
Okay. Yeah.
Uh, First of all, we found that one of the reasons that there was often a lot of overlap between how far bones moved is that
Uh-huh.
they would often have a range of transport distances that they would potentially have. Uh,
Okay.
and that range comes from the fact that just because a bone can move far does
Uh-huh.
not mean that it will. Um, there
Right.
are
Okay.
so many, even in a controlled environment like the one that we had, in which
Mm-hmm.
it was a flat sand bed
Right.
with walls on the side
Uh-huh.
going straight forward with water flowing straight forward and
Yeah.
no other obstacles,
Mm-hmm.
no lateral, like, or not none. There was 3 meters of lateral displacement. That's what you could
Sure.
have.
Yeah.
Uh, and nothing else.
Mm-hmm.
Even in that environment, there are so many things that can stop a bone from moving as
Uh-huh.
far as it theoretically could move.
Interesting.
Um,
So you're getting different ranges of how far these different elements are moving. Even in a really controlled environment, you're still getting that kind of variability.
right, right. And
Interesting.
we we found multiple of these different factors that can stop a bone. You can
Uh-huh.
have in, say, a long bone, just from a physics standpoint, bone starts rolling
Uh-huh.
and it is exposed, this much, like a bounding box of like that
Yeah.
is exposed to flow. And then it reorients itself as it moves through the flow so that now, your bone that was being moved like this relative to water
Uh-huh.
flow is now parallel to flow. And in
Right.
doing that, you've taken what it's exposed to, this area
Mm-hmm.
here, and changed it to a much smaller area. It's now
Sure.
from this
It's
to
become
this.
more hydrodynamic, and so it's
It's
not going to move as far,
way
right? Yeah, yeah,
exactly. So
yeah.
if you have reorientation, it
Uh-huh.
might stop moving.
Right.
If you have interaction between multiple bones,
Uh-huh.
it might stop moving because they're caught on each other and they make a
They're log
jam.
jammed. Yeah,
Right,
yeah.
they log jam themselves or they, bone jam themselves.
Uh-huh.
You can stop them that way. You can
Right.
have ripples and dunes that form out of the sediment that they're on. Interactions
Uh-huh.
with the sediment itself can stop a
Uh-huh.
bone. You can have sediment moving at a faster rate than the bone is moving, which
Mm-hmm.
causes them to scour, which is kind of like when you stand on a beach and the sand rushes out from under your feet,
Right.
causing them to slightly bury themselves. And
Uh-huh.
now they're unlikely to keep moving.
Right.
But on top of that, in floods, floods are temporary, right?
Mm-hmm.
Rivers flow, they have variation in flow throughout the year, but they flow.
Sure. Yeah.
Floods are geologically instantaneous.
It's a stochastic event. Yeah.
Right.
Yeah.
And because of that, you can have multiple repeated flow events.
Mm-hmm.
And in each one of them, they have the chance to move a little and get caught and stop, and move a little and get caught and stop. And the
Right.
more of those factors that can stop a bone influence
Uh-huh.
them, we found that in repeated floods, when we didn't replace the bones after we
Uh-huh.
ran a flood, we just hit them again,
Yeah.
they would move less and less each time.
Interesting. Huh.
They had a tendency to, sort of find their stable spot and
Mm-hmm.
then not move that far afterwards, which
Uh-huh.
suggested to us that, first of all, the first flood that they are impacted with is the
Mm-hmm.
most important. That is the one that really moves them any significant distance.
Gotcha. Yeah, yeah.
Unless if the floods are all roughly the same size, if you get a
Uh-huh.
massive flood afterwards, okay, yeah, then they can move again. But thinking about it from that perspective, that would suggest that if you have multiple similarly sized pulses of floods in a season,
Yeah.
then you might not actually be moving bones on a floodplain that far from where they started.
Which is that was surprising for me to hear because you hear that kind of assumed all the time in the literature that oh well these bones were clearly transported so this animal may not have lived in this environment. You hear that about
Yes.
classically pachycephalosaurs were the example where oh maybe
Yes.
these animals lived
Yes.
in the uplands and that's why they're so rare in this environment and blah blah blah, but it seems like your work kind of challenges that idea.
Yeah, and that's why the whole allochthony versus autochthony thing is important. And
Uh-huh.
I said I wasn't going to say those words again. I said them again. Why the in place versus out of place? What people in the literature will say is in habitat or out of habitat.
Right.
Now, there are some issues to deal with there that relate
Mm-hmm.
to how can we know what the habitat is? We can know what the
Right.
depositional environment is,
Mm-hmm.
but say pachycephalosaurs, we don't know the home range of a pachycephalosaur. We don't
Sure.
know how far they were walking.
Yeah.
Um, but uh, at least within an overbank flow, if you're not in a channel,
Okay.
it seems like from what we saw, each subsequent flood is likely to move you less and less unless those floods are extremely powerful.
Right.
And if you are under those circumstances, looking at the real world geologic, I went through and just looked at overbank flow deposits called
Uh-huh.
crevasse flays.
Yeah, yeah.
These are essentially where uh, rivers will overflow their banks, a levee will break,
Uh-huh.
and a fan of sediment will out over the floodplain.
Right.
Um, and when that happens, you make a fan of sediment
Right.
that thins towards the edges. And those don't, the individual fans, there can be fan sequences that are larger than this, but
Sure.
any individual fan does not tend to be much bigger than a square kilometer or two.
Mm-hmm.
Um, and so if we're thinking on a habitat level, a bone moving 1 kilometer in most
It's not that
cases
far.
is not
Yeah.
going to take you out of the ecological habitat that your organism lived in.
Right.
So
Yeah.
our takeaway from that was probably, unless you have geological evidence to back it up,
Mm-hmm.
you can be pretty sure that your organism did not move a ecologically significant distance if you
Yeah.
found them on floodplains.
Right.
Now, if
Yeah.
they floated on a river, if they were like a full recent carcass that
Mm-hmm.
bloated and floated, all
Yeah.
bets are off. You get ankylosaurs out
Out
in
in
the
the middle of
middle
the
of a
ocean.
seaway, right?
Oh
Like
yeah. Yeah. Mm-hmm.
that's something we can't fully control for. But
Uh-huh.
for disarticulated remains on floodplains,
Uh-huh.
it seems like you don't have to worry too much about them being out of habitat unless you have a weird situation in which you should be able to know that geologically if that's the
Right.
case.
Uh-huh.
And it's something that Ray, I don't know if he talked about it while he was on, but Ray has had that hypothesis for a little while now. And it was part of his thought in running these flash flood experiments was he
Uh-huh.
has looked at the literature
Mm-hmm.
and kind of seen this prevailing thought that we can't trust where fossils are,
Right.
to be reflective,
Uh-huh.
which is a fair question.
Yeah. Yeah. It
But
is one of these things that people just love to repeat, but
right,
I'm glad that there's actually been some real experimentation done to test that idea.
right.
I think that's
Ray
really
is
cool.
kind
Yeah.
of the opinion, and I'm more and more so of the opinion
Mm-hmm.
that your null hypothesis, to throw a little science word out there, your null
Yeah.
hypothesis is the hypothesis that you make that is sort of the baseline, right? This is your
Your default.
baseline
Yeah. It's
assumption,
like, yeah.
right?
Yeah. The
In the
normal thing
literature,
would be for this to be as such. Yeah.
right? In the literature, there is some degree of feeling like the null hypothesis is that I assume that my bones are not in the place that they died reasonably.
Right. Yeah. Yeah.
But maybe really it should be the other way around.
Mm-hmm.
My bones are likely in a place close to where the organism died,
Uh-huh.
probably where it lived, so long as that there is not significant evidence that suggests otherwise.
Mm-hmm.
Um, so we'll see if that holds up, but at least for overbank floods, that might be the case.
Mm-hmm. That's really interesting. Shoot. And I feel like that's reassuring in a way
It kind of
as
is. It's telling you that the taphonomic biases are not so bad that you
right.
can't trust the fossil record at all, which is
Yeah.
nice.
Uh-huh. Yeah, absolutely. Yeah. And I also think it's really cool that your part of your work is saying, "Hey, these things are more complex than we realized." And then there's also that piece of it right there where this is kind of a little bit more simple, where these bones are probably not being transported for multiple kilometers or anything like that. So
Right.
it's a nice yin and yang there. I really appreciate that.
Yeah,
It's cool how that worked out, you know?
transport is
Yeah.
absolutely something that you have to be conscious of,
Sure.
but it doesn't necessarily need to be your baseline assumption.
Right. Yeah.
Um,
No, I like that a
now,
lot.
now there is, speaking of yin and yang, there is a backside of that
Mm-hmm.
where what I'm talking about right now is ecology.
Uh-huh.
I'm not talking about local transport. Local transport is
Hmm.
extremely important. For
Okay.
instance, if you are at a site and you are finding mostly things that in Voorhees's framework you might call group three or two,
Right.
things that don't
Uh-huh.
move as easily, whatever you want to call that on the gradient, the less mobile objects,
Yeah.
um, you can still, within the area of a site, fossil sites can't be that big the majority of the time, right?
Yeah. We
Like,
usually don't have the time or the budget or the
right,
personnel to be able to, dig out a football field size area. Yeah.
right. Like at Lori's site where you saw both of us together last, uh, that, those dig pits are on the order of what?
A few meters.
Maximum, like, yeah, like 5 meters long, maybe
Yeah.
3 meters wide-ish.
Uh-huh.
Um, and that's what you get.
Mm-hmm.
With that site, we might get to work on it long enough that we can push those to be maybe even quite large.
Yeah.
But that's just not how most fossil sites are. And
Right.
so if you're looking within that kind of an area, suddenly now transport matters a lot.
Yeah.
Because you might have some remains of your animal that are 10 meters that way
Mm-hmm.
that you're going to miss because you
Yep.
weren't digging over there.
Yeah. Or maybe there's
Uh,
no outcrop there anymore. It's all been eroded
right.
away
Maybe,
and you're
yeah,
just
maybe
missing it
it's
now.
gone.
Yeah. Yeah.
So locally, transport extremely important.
Uh-huh.
Ecologically, maybe not as big of an issue as people make it out to be.
Right. Yeah. Yeah.
Now, how well that comes into actual channel environments will require more looking at.
Right.
But at least for overbanks,
Hmm.
your floodplain deposits, that's kind of where it landed so far.
Gotcha. Yeah. Very cool. Shoot. While
Thank
you were
you.
talking about how it seems like it's more of a spectrum for some of these elements where there's like a certain range that they're traveling rather than like discrete groups that you can neatly box up like that. Um, I kind of wonder whether in the future, people will be referring to, you know, Chiappone ranges for each of these different elements and how far you might expect them to travel. Uh, Speaking on that idea, how has the reception been for this paper so far? Like, are people happy about it? Because you're kind of upsetting the apple cart at least a little bit. Here's this paradigm that
Yeah.
everybody has been using for the past 50 years, and it turns out that reality is a little bit more complex than that. What sort of reception have you seen so far?
Yeah, so I mean, starting all the way back from when I first started presenting this, I
Mm-hmm.
honestly have generally seen really positive reception to it, which is nice.
Nice. Yeah, yeah.
We weren't purposefully trying to rock the boat. Actually, the
Right.
intention going in was, let's make Voorhees groups for hadrosaurs.
Uh-huh.
Uh, and then it turned out it was more complicated than that, and
Yeah.
we're gonna have to do more to deal with that. But uh, it honestly, a lot of people that I've talked to in the field, at least, not sorry, not in the field, like out in the field, in the
Out in the
field of,
Badlands. No.
yeah. I mean,
Within this
sometimes,
discipline, yeah.
right,
Yeah.
sometimes out in the field, but
Yeah.
specifically in this discipline. Um, a lot of people seem to be of the opinion that this needed to happen, like there
Yeah.
was an unspoken, oh yeah, this is probably the way it is, but we're just not treating it that way kind of deal.
Uh-huh. Yeah.
Which is good to know. Um, but yeah, it is a little bit of a rock to the boat. Obviously, this one paper does not, it's not the end all be all.
Mm-hmm.
There's a reason that I've got more of a PhD to go. We've got a lot more to look at, and there will be a lot more that other people look at as well, besides
Right.
myself. But generally, the feedback has been really positive. I started as a master's student, actually, and as
Uh-huh.
a direct result of presenting this data at SVP a few years ago, I ended up staying on for a PhD
Nice.
because it
Yeah.
felt like there was enough of a project there to keep going. So, yeah, generally, the feedback I've gotten so far has been very positive,
That's awesome. Yeah.
which is nice.
Has anybody been upset yet? We don't have to name names, but
Not really that I've seen.
that's great. Yeah.
The
Yeah.
one really, okay, this was really funny, I will admit.
Okay.
Um, the moment that I was doing floods, I knew that there was potentially a subgroup of people who would
Uh-oh.
gravitate towards this paper if they
Uh-huh.
saw it.
Are you talking
And
about
I,
creationists?
yeah, yeah. Um,
Yeah, of course.
within one day of the paper
Uh-huh.
coming out, there
Yeah.
was already a like creation bulletin news article saying the
Oh
fossil
boy.
record was wrong. And I'm like, no, that's not what I said.
Oh man, I mean, it is a rite of passage, I suppose, to
Oh, it
have
is.
like young Earth creationists pick up on your work and try and use it for their own ends. That's
I
really
just wasn't
funny.
expecting it within
Yeah.
a day. Like,
Uh-huh.
and the funniest part was like the article
Yeah.
they wrote,
Uh-huh.
extremely detailed, well understood. Like they read the paper and understood all of it,
Uh-huh.
and they still got the wrong point.
I
I
mean,
don't know how
if
it
they
was
weren't,
possible. They did, like, they
they're so good at
clearly
that.
have a good basic understanding of how geology. They like define allochthony and autochthony and these different things, and I'm like,
Yep.
wow, that's really impressive. Like this is not ignorance.
Uh-huh.
It's
It's
just a massive misinterpretation, I guess. I don't know.
willful
Um,
misunderstanding. That's kind of the name of the game
I,
with
I
creationism. Yeah,
suppose so.
it's
So that's the
oh
closest thing
boy.
to negative reaction I've gotten, except that they agreed with me, which is funny. So I don't know. Uh, I if I've got even them on
Yeah.
my side, I guess I'm doing pretty good.
There you go. Yeah. Yeah, that's some true outreach for you.
I suppose so. But yeah,
Yeah.
no, the generally within the field, and also in from people that I've had see it from the general public seem
Uh-huh.
to have really thought it was interesting as well, which I appreciate. I'm really glad people are finding it interesting.
Yeah.
Um,
Yeah. No,
yeah,
really cool stuff.
thank you.
Speaking of you continuing on with your PhD, are there any upcoming projects that you want to tease or anything like that? Anything you're
Yeah,
really excited about at the moment?
I can at least talk a little bit about it.
Uh-huh.
So in general, the broad scale direction we're headed next is that we want to take a broad scale understanding of how bone movement works.
Nice.
If
Okay.
the methods that we've been using for the 50 years might not fully be adequate to
Mm-hmm.
understand how bone transport works,
Right.
what can we do that might be sort of the next step? Like, in what places can we make things more quantitative and
Uh-huh.
hopefully more predictive so that we can go out to fossil sites and apply some, either statistics or predictive equations to things that would allow us to understand, okay, what bones are most likely to have moved and what ones are not.
Right. Yeah. That's
Um,
really cool. And I feel like it's the sort of thing that is so broadly applicable. Like just about every field paleontologist who works on vertebrates, at least, everybody who works on dinosaurs especially, would be really excited to have that kind of useful framework. Um,
that's the hope, at least. And we
yeah.
really want this to be something that, like, we're not writing this for any specific part of paleo.
Uh-huh.
It's really we're taking a physics-based approach, right?
Right.
Like, bones,
Mm-hmm.
regardless of who they belong to,
Sure.
uh, are the moment that they encounter water
Mm-hmm.
objects. They are weird shaped sediment, basically.
Uh-huh. Yeah.
Uh,
Bizarre
and
clasts.
so,
Yeah.
right, bizarre clasts. And
Yeah.
so, if we can look at them from a abiotic framework almost,
Uh-huh.
we can try to get at the basic physics of why they move the way they do. And
Right.
that's applicable to any clade, really.
Yeah. Yeah.
Whether that be microvertebrates all the way up to the largest sauropods.
Gotcha. That's really cool. Wow. Um, I wonder how long it's going to be until you get your first citation on this paper. I presume it's going to come pretty fast.
I don't know. We'll have to
I
see.
I think a lot of folks are going to be citing this. I hope so, at least. Like this is
I
really cool
mean,
stuff. And
I also hope so for obvious reasons, but
yeah, yeah.
the second paper I'm hoping will be the really broadly applicable one. That would be,
Okay, nice.
the way that we're going with it is trying to make it useful in most flow environments for most animal taxa.
Uh huh.
We've already done a lot of the experimental work on it. It's already well on its way.
Uh huh.
Um, and so hopefully this will be useful to people. Yes, there is a degree of please cite my paper, but also uh the my
You
real
want to just
hope for
contribute to the field, you know? Like you
yeah
want.
my well my real
Yeah.
hope is that it's useful to people. I want to write
Right.
something that is useful more
I
than
think
anything
that's
else.
really all that any of us hope for as a scientist is just that other people find our work useful and they're able to use it to make their research even better. Yeah. So, well said, Michael. Before we wrap up here, I often like to ask interviewees if they have any advice for anybody in the audience who might want to get into science, whether they're a student or whether they're a retiree or whatever, whether they're pursuing a career in science or they're looking for ways to get involved with fieldwork or fossil prep or whatever. Any bits of advice, wisdom that you can hand to them here?
Yeah, this is sort of a, like, what direction you want to go
Uh
kind
huh.
of piece of advice. Never underestimate what you might be interested in.
What do you
Um,
mean by that? Huh.
when I came into undergrad,
Uh huh.
I was a dinosaur kid. I was
Right.
fully a dinosaur kid. That's what I wanted to do. I wanted to do
Yep.
dinosaurs.
Uh huh.
Um, and I went through geology, and I fell in love with geology.
Uh huh.
And then I did research in my undergrad lab, in which I was looking at, in sort of a broad way, it was kind of related to dinosaurs and that it is birds,
Yeah.
but it was looking at the evolutionary origins of their vocal organ, which was mostly
Right.
biological work.
Uh-huh.
and I fell in love with birds and birdsong and the way that animal vocalization works.
Right.
And then I got done with that and I went on field camp at the end of my geology tenure and absolutely fell in love with field geology. I loved going out and I mean, I already loved being outside, so it probably, helped a lot, but
Mm-hmm.
putting my hands on the rock and interpreting the depositional environments that got them to
Right.
where they are today,
Uh-huh.
like trying to, visualize ancient landscapes in my mind led me towards taphonomy, which is sort of a subsect of, you know, telling the stories of ancient landscapes.
Right.
None of these things are things that I thought I would be interested in coming
Yeah.
into undergrad. And if I had completely like stuck to my guns and been
Yeah.
closed-minded about it,
Mm-hmm.
I would have just probably done dinosaurs and nothing else.
Mm-hmm.
And I don't think I would have been nearly as good of a scientist as I'm trying to be now.
Mm-hmm.
I mean, heck, even just within grad school, not even the broad scale stuff,
Yeah.
I didn't come into grad school thinking that I was going to learn fluid dynamics. And yet,
Right. Yeah.
here I am today in the lab, sitting there going through like calculating drag coefficients of bones and the
Uh-huh.
frictional coefficients of them and like what cross-sectional area is exposed to flow and what the Froude number is of the flow and all these different things that I would never have thought about. But
Right.
because I allowed myself to be open to it, and especially because I have a really great committee of people who oversee my PhD that includes two paleontologists, a fluid dynamics engineer, and
Mm-hmm.
a phenomenal geologist named Chris Paola, who has helped me fall in love with the processes of sediment transport and the way that rivers work in a way that math terrified me, coming out of high
I can relate.
school.
Yeah, yeah.
Like, suddenly I'm somehow finding math beautiful now. And if I told myself that when I graduated, I would have like fainted, like on the spot.
Yeah.
So the world is fascinating, and there are so many interesting things out there
Mm-hmm.
to chase that, are worth looking at the forest for the trees.
Right. Well
Um,
said. Yeah.
so yeah, never underestimate what you could be interested in.
I think that's really good advice. Yeah.
Thank you.
Um, Before I let you go, need to ask, is there anything you'd like to plug? Where can people find more Michael Chiappone?
Yeah, so I am less social media oriented than I used to be, but I am on I'm not on well, sort of the account still exists on the place that used to be Twitter.
Ugh, yeah.
Uh so it is there,
Uh-huh.
but I'm not on there very much. I'm also
I'm not
not
either. Yeah.
on Blue Sky very much, but I am there and I did post a lot about my recent publication. So that's it. My last name Chiappone Nature uh, dot B Sky Social.
Uh-huh.
Um, so you can find me there. You can also just look for my name and I'll be there. Um, I also am more prominently, I feel like, on YouTube at Earth Encompassed. That's where that video was. I haven't gotten to do nearly as many of those as I want to do because
Right.
I tend to go for kind of long form documentary style content, which means it takes a long time. But
Mm-hmm.
that is one of the places where you'll see me the most. So absolutely feel free to go check me out over there.
Excellent. I'll put a link in the chat again. Everybody should take a look at this video. Give it a thumbs up and leave a comment. Do all the YouTube stuff. You know how this works, chat. Like I said before, I would love to see more researchers produce videos about their work if they have anything close to the sort of skill set that you have, Michael. This was a really phenomenal video. The cinematography and the editing and the narration and the music. I mean, holy cow!
Oh, I
Was that
suppose
all your
actually.
original music there?
So yeah, okay, I should talk about that. First of all, before I talk about
Yeah.
this, I do hope going forward to do more shorter, like easier to get out videos that
Uh-huh.
are like of a similar style but are a little shorter. So hopefully you will not have to wait 3 years for the next thing to come out. Uh,
Excellent. Yeah.
Bother me if I don't because I probably need it. But uh, so yes, the music. This is another case of don't underestimate what you're interested in. I don't come from a science family. I am the first scientist in my family. I am one of the first to graduate college in my family. Certainly, at least in my immediate
Uh-huh.
family, I am the first. Um, and what I do come from, though, is a music family. My parents are both musicians, and so going into high school when I started, or well, sorry, middle school even, uh, started playing trumpet and immediately fell in love with it. And
Nice.
uh,
I did
I
trumpet
have
in middle school and high school too. It's a cool
amazing.
instrument. Yeah.
Yeah, it's fun.
Yeah.
So I fell in love with music a bit. And even though I didn't play as much in college, I did study animal vocalization. So sound has always
Right.
kind of weaved its way through my life a little bit.
Uh-huh.
Uh, and coming into this video, really coming into the paper, actually, I should start there. The paper is called When the Levee Breaks,
Mm-hmm.
experimentally testing mammal and dinosaur bone transport in unsteady flows. Uh, that is an intentional reference to
Right.
the, I would say the Led Zeppelin classic, but it actually predates them.
That's a cover, right? Yeah.
It's a cover by Led
Yeah.
Zeppelin of a 1920s blues song about the 1927 Mississippi floods,
Oh.
which were these historic generational floods that ran a lot of people out of their homes. And I
Mm-hmm.
actually learned recently indirectly kicked off rock and roll a little bit
Really?
um,
Huh.
because a lot of the folks that were living down there were African American in origin, and
Uh-huh.
they were working in, frankly, pretty terrible agricultural conditions a lot of the time. This is
Sharecropping and stuff like that. Yeah,
yeah,
yeah.
things like that.
Yeah.
And so when they were, evicted from their homes by this flood,
Mm-hmm.
a lot of them moved north to places like Chicago, which in
Okay.
the Led
Yeah.
Zeppelin version of the song, they actually directly add a new lyric that talks
Uh-huh.
about this when they say, uh, uh, if you're going down south, there will be no work to do, so get on up to Chicago.
Uh-huh.
Um, that is a direct reference to what happened after these floods, and they
Uh-huh.
took their music with them. They
Uh-huh.
took these blues songs that they were making down south and took them up to these places like Chicago, where electrical equipment, electrical guitars,
Yep.
became a lot more popular in ensuing years,
Mm-hmm.
eventually leading to the American style of blues rock and roll, which I think is phenomenal. It's
Right.
so,
Yeah.
so interesting that this song sort of encapsulates early rock and roll
Mm-hmm.
through a flood that happened. And
Right.
when I was trying to name the paper, I got with Ida, who was in the chat earlier, and was like, "You are really good at naming things. I am having such a hard time naming this paper because I wanted it to sound interesting. I didn't want it to just be a
Sure.
jargony mess.
Dry sounding. Yeah, yeah.
Because taphonomy, frankly, is often seen as kind of dry and jargony as it is. It's
Mm-hmm.
not the most popular field within paleontology, I'll say that. Uh, and so I got with her and I got with Ray too. And Ray
Mm-hmm.
was like, what if it's a song name? Like initially we thought about doing Proud Mary rolling down the river,
Yeah, yeah. Uh-huh.
or rolling on the river.
Uh-huh.
But I was like, there's got to be a song that encapsulates like flooding and stuff like that. Surely there are so many like flood songs.
Yeah.
And there are like your there's a similar story with Stevie Ray Vaughan's cover of Texas floods. It's flooding down in Texas. Similar
Huh.
thing. Also
Uh-huh.
originally a blues song from I forget
Right.
when. Uh, so I went to Ida, and Ida was like, "Well, what about Led Zeppelin? What about When the Levee Breaks?" And I was like, "Oh my God, of course,"
Yeah.
because that was about the Mississippi River floods.
Uh-huh.
We were using the Mississippi River to make floods.
Hmm.
The Mississippi River was flooding into the building to make our experiments happen. So from the
Right.
moment that I looked into this song, I was like, oh, that's it. That's
That's so
what this
cool.
is. That's the name of, okay. Uh, so for the video, yes, I composed all the music from scratch. Um, I also, for the video, in both the intro and the ending of the video, are a cover of that song, When the Levee Breaks, that a couple of friends and I put together. Uh, People I've met here in Minneapolis who play cello and electric guitar, and then actually my dad is playing drums.
Nice.
Uh, when I went home for Thanksgiving, we
Uh-huh.
popped a few mics around, and he did that really classic Led Zeppelin, backbeat. Um, and I played the acoustic guitar, electric guitar, harmonica, trumpet, and vocals,
Hmm.
which I had never done vocals for a song before, so that was a lot of fun to try. Um, and so yeah, there's within, it's maybe not in, I suppose it kind of does interweave with the science given the name of the paper, but
Yeah.
certainly within the outreach part, there is still this aspect of music following me around.
Hmm. That's
Or,
really neat. Yeah.
yeah,
I
yeah,
remember you talking about this when we were in the field together back in September. That you were looking for somebody to do percussion on the track and all of this, and you were so
yeah,
excited
yeah.
about it. And I'm like, this is going to be really cool, isn't it? And the video does not disappoint.
Thank you very
It is
much. I'm
excellent.
glad you
So again,
enjoyed it.
anybody in the chat, if you haven't seen it yet,
Yeah.
Claire just put the link in there. Give it a thumbs up, leave a comment.
Yeah,
All
I guess that's another thing I can plug is
Yeah,
that given that we put all the work into making the cover, I am
yeah,
planning on releasing the cover on its own soon.
nice. All right,
I'm
yeah.
trying to do some cover art for it first,
Uh huh.
but this will be the first piece of music I've ever put out like on its own. So
Uh huh.
I guess keep an eye out for that on all of the aforementioned places.
Very cool. Yeah. Awesome. Well, thank you so much, Michael. This has been a blast talking with you, and
Yeah, of
congrats on
course.
the new paper. I think it's I think it's going to make a difference to a lot of people. So
Thank you
I
very
appreciate it
much.
on that level, and the outreach that you're doing with this is really cool. Thank you again for suggesting this interview and reminding me about it.
Yeah, thank you
Apologies for
for
it.
having me.
Yeah, yeah. Apologies. It took a few days to make this happen, but I
Oh, don't
appreciate your
worry about it.
flexibility, and this
Yeah,
has been
yeah.
great. So anytime
Yeah,
you've
and
got another
if
paper coming out, just let me know, and I'll promote it here, and it'd be a joy to talk about it. So
thank you very much. Yeah, if
yeah,
anyone has questions, I am happy to answer them.
perfect. All right.
Yeah,
Thanks again, Michael. Really appreciate it.
yeah.
All
Thank
right,
you very
take care.
much.
Bye
Have a
bye.
good night.